Okay, so let's look at our first example here. 2 is the first term in this sequence. And these are not typical geometric or algebraic sequences. So to go from 2 to 4, we know we had to multiply by 2, but then we had to subtract 1 to go from 4 to 3. Go from 3 to 6, we multiply by 2, and we subtract 1, multiply by 2, subtract 1, multiply by 2, subtract 1. So find the next 3 terms in the sequence. So 17 times 2 is 34. Subtract 1 is 33. Times 2 is 66. And then subtract 1 is 65. Well, I found 4 terms in the sequence, and we only had to find 3. So follow the pattern. This is not your typical geometric or algebraic. These patterns are going to be a little bit different. Okay, so what is the 11th term in the sequence? 1, 4, 9, 16, 25. 1, 4, 9, 16, 25. So what's going on here? 1 to 4 is adding 3. 4 to 9 is adding 5. Adding 7. Adding 9. I think we're going to add 11 and get to 36. I'm going to add 13 and get to 49. Add 15 and get to 64. Add 17 and get to 81. Add 19 and get to 100. Oh, look, these are perfect squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got to add 21 to get to 111. 121. I'm sorry, 121. Wow, the 11th term in this sequence is 11 squared. So these are our squares. Look at that pattern fall out of the sky. So if you can't remember your perfect squares, just add an increasing odd number in between each term, and you will get there. All right, so let's look at example 3. We started with 3, and we added 1, 2, 3, 4, which means 3 plus 4 is 7. So 1, 2, 3, 4, 5, 6, 7. We added 3, 4. So 7 plus 4 is 11. So find the next 3 terms. So let's draw it out. So plus 4 should be 15. Right? Bank, 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 bank. So we got 1 up triangle, 2 up triangles, 1 down. 1, 2, 3 up triangles, 2 down. And we should get 5 up triangles and 2 down. So 1, 2, 3, 4. My drawing gets kind of wonky here. So let's see how many sides we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we should add 4 again. So let's see. We got 1, 2, 3, 4 up triangles, 1, 2, 3 down. So we should add 1 down and 1 up. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So we're adding 2 other triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9. So count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, which is plus 4. and the next one should come out to 23. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And those are the next three terms in the pattern, or I could have just written the numbers down. But I think it was better to draw it out. Okay, so those were our three examples. Try to practice problems, and I will see you at the end of the video for a review. Okay, extend the pattern by three terms. So we got 1/2, we got 1.5, we got 3.5, 4.5, and then 6.5. So what's going on here? So we added 1, then we added 2, then we added 1, then we added 2. So add 1, you get 7.5. Add 2, you get 9.5. Add 1, you get 10.5. So let's see, we went from 6, 1, 2, 3. Oops. That comma is not in between 9.5. 9.5 is one number. All right, so that looks like it. Okay, problem 2. What is the 9th term in the sequence? 1, let me turn my pencil back on, that might help. 1, 2, 6, 24, 120. Okay, what's going on here? So, what do you multiply by 2, then by 3, then by 4, then by 5. Ugh. Then by 6. So what's 120 times 6? 720. Is 720. Then multiply by 7, and we get 720 times 7 50, 40 times it by 8. We have 40,320. All right, let me erase this comma. I have a bad habit of putting commas in. Okay, and getting back to the pencil. All right, 1, 2, 3, 4, 5, 6, 7, 8. I guess we had to multiply by 9 to get there. We get 362,880. Okay, so that's the 9th term in the sequence. No recursive or explicit formulas because the constant is not the same. So these patterns are a little goofy. Okay, find the next 3 terms in the pattern. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9 hexagons. That's pattern 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 hexagons. So we went up by 5. So let's see what we go up by here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh, look at this. We went up by 5, then by 5 again. So pattern 4, so I'm going to call it P4, is 19 plus 5, which is 24 hexagons. And I'm not going to draw it because I don't have the space. P5 is 29 hexagons. And then P6 has 34 hexagons. So that is our lesson on algebraic patterns. So these patterns, except for this one, these patterns did not go up by the same number each time, but the last one did. It went up by 4 each time. So algebraic patterns, you're going to have to pay attention to the shapes, and you're trying to get the shapes do something. So thank you for watching this video, and I hope that you subscribe and get notifications, and I will see you in the next video. And we are done with sequences and patterns, and so the next videos we're going to start with functions.